Hello all, welcome to the 64-bit edition of the Security Tube Linux Assembly Expert course and certification. Now in this video, we will take up the Execve shellcode and look at how to implement it using the jump call pop technique. Now it's important to note here, as we mentioned before, that there is no need to write the exit part of the shellcode simply because once execve successfully runs, pretty much the existing program gets overlaid by whatever we call within execve. Okay, so just a quick recap from the previous video. We need to ensure that RDI contains the address to bin sh and argv contains basically the address to the array of inputs, which basically has to be the address of bin sh followed by null, as we do not want to pass any further arguments. And finally, envp needs to again contain the address to a null, right? And the respective registers involved are RDI, RSI, and RDX, right? Okay. So what is the approach? Here is what we are going to do. So let's say we have the string bin bash or bin sh, and after that we are going to have a placeholder for a single byte with which we will null terminate this string, followed by 8 bytes. For the time being, we have the placeholder value, all B's in it, followed by an additional 8 bytes of all C's in it. Now, first we are going to use the jump call pop technique to find the address of this string in memory. And if you've seen previous videos of how we use jump call pop, you already know how to do that. So once we find the address, we pop it into the RDI register, which points to bin bash. The second step is going to be converting the A to a 0x0 so that the string is null terminated. Now the third step would be to convert these all B's into the address of bin bash in memory. And finally, the last step is going to convert the 8 C's into another null or all zeros. And once this is done, we pretty much have our inputs for the syscall setup, right? So RDI would need to point to the null terminated string. So here it is. RSI would need to point to an array of arguments, of which the first is the address to bin bash. Here it is. Here is RSI. And finally, RDX needs to point to a null, and we can make it point in here. So with this background, let's jump into the program and see how we are doing this. I already have the base code written, but we'll go through it step by step. Now at the very top, I'm using the jump call pop technique. So I'm doing a jump to find underscore address, which is in here. And this basically calls the shellcode here on top. And this call ensures that the very next address is pushed on the stack. And this really contains the address to this entire string, which is bin sh or bin bash. You can use either. I'm using bin sh in the actual program so that we can perceptibly see the prompt change when our shellcode executes. Now followed by the single A, and then we have the 8 B's, and then finally the 8 C's, just as we discussed in the slides. So once call shellcode is called, we are in here. Now at this point, the top of the stack contains the address to this long string in here. And we are going to get that address from the stack and store it in the RDI register using a pop RDI. Now, if you recall, RDI anyway has to point to this string, and hence RDI is now all set up. Now, the next step was to convert, if you kind of go back in here, was to convert the A into a null or a 0x0. Now, this can be done very easily by just calling a move RDI plus 7, comma byte AH. So this overwrites A, which is really at RDI plus 7 with 0x0, and ensures that now bin sh is null terminated. Now the next step is to write the 8 Bs over with the address of bin sh. Now if you recall, the address of bin sh is stored in RDI, and all we are going to do then very simply is move RDI into RDI plus 8, which is really these 8 Bs. So the 8 Bs get overwritten by the 8-byte address of the string currently stored in RDI. Finally, we need to overlay all our Cs with 8 null bytes. That should be simple because of the XOR RAX. RAX is currently 0, and a move RDI plus 16, RAX is going to ensure that all the 8 Cs are overwritten with zeros. Now finally that is done. All we need to do is ensure that RSI contains the address pointing to the argument array. So we are going to do a very simple LEA RSI, RDI plus 8 so that it points in here at the beginning of this space, and then RDX needs to point to the null, which is nothing but 8 bytes further, which should be exactly this location. So once this is done, we change the value of RAX to 59, which is the syscall number for Execve, with a simple add RAX 59, and then we call our syscall, right? Fantastic. So let's go ahead. Let's assemble it, and then let's link it, and let's go ahead and get the shellcode. You can use the executable or the O file. Let's copy the shellcode out. Use shellcode.c. Paste this in there. Compile it. And there we go, right? Our bin sh is now executed via the shellcode. So jump call pop hopefully has been interesting. And in the next video, we will take GDB and analyze and see how the entire string gets overwritten and modified to run the Execve shellcode. So hopefully you've enjoyed this video, and if you're overall liking what you see at Pentester Academy, then we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you.